Hello and welcome to the video. In this video, I'm going to be going over finding the derivative of an inverse function. So we already kind of did this with inverse trig functions, but now I want to show you how to do it for any function. So last video I said that that would be the final video before the applications of differentiation, but I did forget that we have to do this. So let's get into it. For finding the derivative of f inverse of x, we don't know how to do that right now. What we do know how to do is how to differentiate a function normally. So what I'm going to do is I'm going to let y be f inverse of x. So we don't know how to differentiate this and find dy dx just yet, but what we do know is we can turn this into something else. We can say, because y is f inverse of x, this has to mean that x is f of y. Now, this is actually something we can work with. If we differentiate both sides with respect to x, the left side will just become 1, and the right side will need the chain rule, but we'll be able to have our derivative. So let me differentiate both sides with respect to x. Okay, so the left side, like I said, is just going to be 1. The right side, we need the chain rule. So our outside function is f, and our inside function is y. Chain rule says that we do the derivative of the outside evaluated at the inside, all multiplied by the derivative of the inside. The derivative of the outside is just f prime of x, but we evaluate that at the inside, so f prime of y multiplied by the derivative of y, which is just dy dx. So to find dy dx, we can just divide by this, and we'll get dy dx is equal to 1 over the derivative of f evaluated at y. But what is y? Remember, we want this derivative to be in terms of x, but we have what y is. We have that y is equal to f inverse of x. So if you replace this y with f inverse of x, we get that dy dx is 1 over f prime of f inverse of x. So this might be a little trippy about like what this actually means. Basically, you find the derivative of your function, your original function. You do 1 over that, but instead of having x on the inside, you evaluate it at f inverse of x. So the two things that you need for this formula for finding a derivative of an inverse is the derivative of your original function, which is f prime of x. And you also need to know what the inverse function is. Now, I'm going to show you an example later where you might not know the general formula for the inverse as a whole, but if you have specific points on a function or you know specific ordered pairs, then you can apply this to specific points. But let's do some examples. So I previously gave you the derivative of the sine inverse of x, but I want to use this formula that we just found to show that. We're given that y is sine inverse of x. For our derivative formula, we want to have that y is f inverse of x. So this is just f inverse of x, where f of x is just sine of x. So to find dy dx, our formula tells us that's 1 over f prime of f inverse of x. Well, f prime of x, what's the derivative of sine of x? The derivative of sine of x is just cosine of x. Well, what is this piece in the middle? We're already given that f inverse of x is just sine inverse of x, right here. Using what we know, this becomes 1 over cosine of sine inverse of x. Okay, so, you could leave it like that, but there's some simplifications that we can do using trigonometry, so I just want to show that. So let's draw a right triangle. And let's call this angle theta. So, let's just say that sine of theta is equal to x. Okay, so we have this as x. That's the same thing as x over 1. And remember, sine is opposite over hypotenuse. So we can draw this right triangle where x is the opposite and the hypotenuse has length 1. So we're given that our hypotenuse, it has length 1. Our opposite side has length x. Well, the adjacent side is then given by the square root of 1 minus x squared, because it's the square root of c squared minus b squared. Okay, well, if we find cosine of theta, we know that because sine theta is x, that means that theta is sine inverse of x. We know that cosine of theta is just going to be cosine of this, because these two things are equal. So it's going to be cosine sine inverse of x. Our ultimate goal is to get expression for this cosine of sine inverse of x. But we also know that cosine of theta is going to be adjacent over hypotenuse. So square root of 1 minus x squared over 1. Well, that 1 doesn't matter. So we're given is because cosine theta is adjacent over hypotenuse, but it's also equal to this, we can say that these two things are equal. So we know that cosine of sine inverse of x is the square root of 1 minus x squared. So this becomes 1 over the square root of 1 minus x squared. And that is our final answer. And if you remember, that is the same thing that we get for our derivative of inverse sine. Let's do 2 more examples. So if we're given that f of x is negative 1/8 x cubed minus 3, we want to find the derivative of the inverse function evaluated at negative 5. Alright, first up, let's just write out our formula. We know that at negative 5, the derivative of the inverse is going to be given by 1 over the derivative of the original function evaluated at the inverse of negative 5. We're just plugging this negative 5 in where the x would normally go in the formula. Well, what is the f inverse of negative 5? Basically, what we're asking is what value of x generates an f value of negative 5. That is x equals 4. So this is going to be 1 over f prime of 4. So basically, we're just asking now, what's the reciprocal of the derivative evaluated at 4? Well, to find this out, we need to find out what the derivative of the original function is. By our power rule, this constant's just going to go away. And then we can bring that 3 down. So negative 3/8, and reduce the power by 1. So negative 3/8 x squared. If we plug in 4, we get negative 3/8 times 4 squared, that's 16. And then 16 over 8 is just 2. So negative 3 times 2 is just negative 6. So we would get 1 over negative 6. That is negative 1/6. Alright, this second part asks us to find a general formula for f inverse of x, and then use that to find a general formula for the derivative of the inverse function. We have that y is equal to negative 1/8 x cubed minus 3. This is the same thing, we're just writing it with y instead of f of x. To get the inverse, we just solve x is equal to negative 1/8 y cubed minus 3. Well, the first step is just to isolate all the stuff with y, which is on the right side. So let's add 3 to get rid of that negative 3. And then what we'll get is negative 1/8 y cubed is equal to x plus 3. Now let's multiply both sides by negative 8 to get rid of this constant. We get that y cubed is equal to negative 8x plus 3. And then if we take the cube root of both sides to undo that y cubed, we get that y is equal to, let's do this negative 8 and that x plus 3 separate. The cube root of negative 8 is just negative 2 times the cube root of x plus 3. So that is the general formula for our inverse. We can replace this y with f inverse of x. This inverse is just a function. To find the derivative of the inverse function, we just take the derivative of this negative 2 cube root of x plus 3. So we'll get that f inverse prime of x is just the derivative of negative 2. I'm going to write this cube root using a 1/3 power. X plus 3 to the 1/3. We can pull this 1/3 down using the power rule, and this constant just gets pulled out. So this would be negative 2/3 x plus 3 to the negative 2/3 by our power rule. And then the derivative of the inside with respect to x is just 1, so we can just ignore that. So this is our formula for the derivative of f inverse of x. All right, one more example. All right, for this example, we're given this function right here, and then we want to find the derivative of the inverse function at 0. Well, we know this is just going to be 1 over g prime, so the derivative of g, evaluated at g inverse of 0. So what is g inverse of 0? Basically, we're just asking where is the function g equal to 0. And that happens when you plug in x equals 3, which is right here. So we can rewrite this as 1 over g prime of 3. Well, we need to know what g prime is. The derivative of g of x, g prime of x, is given by the derivative of x minus 3 e to the x. This just requires a product rule. So for this first part here, the derivative of that is just 1. So 1 times e to the x plus, what's the derivative of e to the x? That's just e to the x. So we'd have the other term, which is x minus 3, times that derivative, which is just e to the x. Okay, now plug in 3 to that. If we plug in 3, we get e to the 3rd power plus 3 minus 3 e to the 3rd power. This is just 0 because that 3 minus 3. So this is just e cubed. So this in the denominator is just e cubed. So overall, this is 1 over e cubed. Thank you for watching the video. I hope that you found it helpful. In the next video, I'm going to actually start going over some of the applications of differentiation. Anyways, this probably won't be a very heavily tested topic in your calculus course, but I still think it's good to go over it. In the next video, I think I'm going to start going over some relative extremum and intervals of increasing and decreasing. So I will see you there. Anyways, have a good rest of your day, and bye-bye.